In section 2.3, we're going to be talking about linear functions and slope. To start off, linear functions are like what's pictured here. They're a straight line, and so oftentimes we look at linear functions by using 2 points somewhere on the line, and we can measure the slope of the line by using this formula, m equals rise over run. The slope formula basically measures the steepness of the line passing through two coordinates x1, y1 and x2, y2. And to calculate rise over run for the slope, we do y2 minus y1 divided by x2 minus x1. For equations of straight lines or linear functions, we can use what's called the point-slope form, which is y minus y1 equals mx minus x1. There's another one called the slope-intercept form for equation of a line. That's y equals mx plus b. Then the equation of a horizontal line is y equals b. So if it's flat and horizontal, that would be the equation of the line. And x equals a is the equation of a vertical line. And then one other type of equation is called the general form for the equation of a line. And it goes ax plus by plus c equals 0. One by one, we're going to go through each one of these types of equations and go through graphing and the lines and the different types of linear functions that go along with them. We're going to start by looking at just the slope of a line by calculating the slope through 2 points, starting with this one that has -3, -1, and -2, 4. So for the slope formula, we'll think as the first number as x1, y1, and the second point as x2, y2. And if we plug those into the slope formula, on top, y2 minus y1 would look like 4 minus -1. And underneath, x2 minus x1 would look like -2 minus -3. When we calculate the numbers for that, we get 5 divided by 1, or just 5. And so that would be the slope of the line passing through those 2 points. I've plotted the 2 points so we can see what the slope looks like here. And again, slope can be thought of as rise over run. So the rise is a 5, the run is 1. So it goes forward 1 and up 5 with this particular slope. We can also see, since it's a positive slope, the line will be rising from left to right. For the next set of points, -3, 4, and 2, -2, if I plug those numbers into the slope formula, it would go -2 minus 4 divided by 2 minus -3. And when I calculate that, I get -6 divided by 5. This is what the 2 points would look like with a straight line drawn through them. In this case now it goes forward 5, but then goes down 6. Since it's a negative slope, we actually have the line falling from left to right. Some other examples here, 4, -1, and 3, -1. In the slope formula, we get -1 minus -1 over 3 minus 4, which when we calculate that turns into 0 divided by -1, and 0 divided by anything is equal to 0. So the slope is equal to 0. And with the line passing through those 2 points would actually be horizontal. So what this makes the connection is, if it's a 0 slope, then the line passing through the points will be a horizontal line. And for the next 2 pair of points, 3, -4 and 3, 5, plugging those into the slope formula, we get 5 minus -4 divided by 3 minus 3, which will actually turn into 9 divided by 0. Divided by 0 is undefined. We'll actually get a vertical line passing through these 2 points. And so the connection is that if it's undefined slope, then that goes together with a vertical line. Now we're going to go through a few examples of using the slope formula, but also using some of the other equations of a line, such as point slope and slope intercept form. The first example here says, at one part of the road to the summit of Pikes Peak, the road rises at a rate of 15 vertical feet for a horizontal distance of 250 feet. Find the grade of the road. Well, here's kind of the situation that's going on. If you go forward a horizontal distance of 250 feet, then the rise is 15 feet. So the road is going up through it like so. So we'll figure out is to know how steep this is, we'll consider the slope of the road. Slope, again, we can think about as rise over run. And in this case, we know the number for rise is 15 feet divided by the run forward, which is 250. So when we divide 15 by 250, it comes out with 0.006 as a decimal number. And so generally when they talk about the grade of a road, it's coming from this slope number as a decimal turned into a percentage. So if I change 0.06 into a percentage, I just shift the decimal point over 2 spaces, and that would be the same as 6%. So the grade of a road is the steepness of the road expressed as a percentage, which is calculated by doing rise over run for the slope. This next one says, write the equation in point slope form for the line with the slope of -2 and passing through the point of 2, -4. And then from there, we're going to solve for y. So this involves writing the equation of a line, and it says specifically point slope form. So we'll look at the y minus y1 equals mx minus x1. The point 2, -4 will be our x1 and our y1, and the slope is for the letter m. So if I put those numbers in here, it would be y minus -4 equal to -2 x minus 2. So that's the point slope form way of writing the equation of the line. And then from here, we'll go ahead and solve for y. We can go ahead and make this into y plus 4 is equal to, and I'll distribute the -2 to the parentheses to get -2x plus 4. Solving for y, we'll subtract the 4 over and get y is equal to -2x. On this one, it says write the equation in point slope form for the line through the points 4, -3, and -2, 6, and then solve for y. Okay, so we're going to have to use point slope form. Beyond this, however, we don't have the number immediately for m, but we do have 2 points, and we can calculate the slope m by using these 2 points. So for our x1, y1 will be the first point, and x2, y2 will be our second point. So step 1 will be to go ahead and calculate the slope. So m would be equal to 6 minus -3 all over -2 minus 4. So that on top would be 6 plus 3 divided by -6, or 9 divided by -6. As a fraction, that would reduce down into -3 over 2. So that's the slope for our line through those 2 points. I can then plug these numbers into the point slope form using our point for x1, y1. It would go y minus -3 equals -3 over 2 x minus 4. So for here, we'll go ahead and solve for y. Let's change this into y plus 3, and then we can also distribute the fraction -3 over 2, make it -3 over 2x, plus, and if I multiply the fraction by the 4, negative 3 over 2 times negative 4 would be positive 12 over 2. Or we could reduce that down into just 6. So to solve for y, I'll subtract the 3 over from both sides. So the equation of this line solved for y would be y equals negative 3 over 2x plus 3.